All right, calculus students, welcome back to the third and final video for section 4.5. So the one thing that we haven't done with u substitution is look at definite integrals. We've just been looking at the indefinite integrals or the antiderivatives. And so this is the last thing we need to do. So we're going to be looking at definite integrals and u substitution, and we're going to be using the method of changing the variables, which is generally a lot more efficient with these when using u substitution. So let's just go through an example and I'll show you how to use change of variables. So for example, let's say I have the integral from x equals 0 to x equals 1/2 of sine of pi x dx. So you can kind of see right away that we're going to have to use a u substitution. But here's what's really important. Please notice that here we have our x that we're integrating with respect to, and these are a and our b, the limits of integration, are in terms of x. So whatever variable you have here, your a and b has to be in terms of that variable. So here x is equal to 0 and x is equal to 1/2, and that matches with this x here. Okay, and we'll deal with that shortly. Now the first thing we want to do is we can recognize that we have to use u substitution for this particular problem in order to find the antiderivatives that we need for the definite integrals. So the form, I keep doing that. All right, the form that we're looking for is the integral of sine of u du from some a to b is going to be equal to minus cosine of u from a to b. But here's the thing, and this is really an important thing, is that this is a u here, and so my a and b cannot be in terms of x. It has to be in terms of u. Okay, so we'll deal with that in a moment. I just want to kind of show you that that's what we need to do. Okay, so first thing I'm going to do is I'm going to first treat this like any u substitution. So I've got, I'm going to let u be equal to, here I'm going to use the trig rule because the sign is not to a power. So I got u is equal to pi x. So this becomes just sine of u. And then I still need to substitute my dx. So I'm going to lock that up. And I'm going to take the derivative, so du is equal to pi dx. And if I solve for dx, which is what I need to substitute, that's equal to 1 over pi du. So this is 1 over pi du. Okay, so far so good, same as what we were doing before. So I've got this is equal to 1 over pi times the integral sine of u. But here, I cannot put, okay, now watch carefully, I cannot put this 0 and 1/2 down here because this 0 and this 1/2 belong to the x. But now we've got ourselves du. All right, here we go, du. So notice that, what in the world? Okay, here we go. So here I've got du, and so I can't put this 0 and 1/2 in here because that doesn't belong to u. So what we have to do is we have to change our variables. Okay, seriously, I will get this program at one point. Okay, so change the variables. Okay, so I want to change the x's from the original definite integral into u's. So I'm going to rewrite my u here. So my u is pi x. That was my substitution. So when x equals 0, which is the lower bound of the integral on the original integral, then what I need to do is get this in terms of u. So then u is equal to pi times x. Well, when x is 0, u is 0. And when x is equal to 1/2, then u is equal to pi times 1/2, which is pi over 2. Okay, so what I can do then is I need to put these back into my integral over here. And so then my lower bound is, I'm going to write u just to remind myself that it needs to be in terms of u. So u goes from 0 to u goes to pi over 2. So do not use the x's here. If just make sure you change your variables to u. Okay, so now I treat this like a regular definite integral. So I've got 1 over pi times the antiderivative of sine of u, which is minus cosine of u, evaluated from 0 to pi over 2. So this is going to be 1 over pi times minus cosine of pi over 2 minus a minus cosine of 0. Okay, so I know that cosine of pi over 2 is 0, and cosine of 0 is 1, so I've got minus 1, so that's a positive 1. So this definite integral is equal to just 1 over pi. And that represents the area bound by this function, the x-axis, and the interval a to b. Okay, so this is a little tricky, so let's kind of just review this. Okay, so I know I need to use a u substitution, but for definite integrals, these are always going to be in terms of x. So once I make my substitution, instead of putting this 1/2 and 0 here, I need to get u in terms of, I need to get these a and b in terms of u. And I do that by looking at what I used for the sub, and then change my variables so that everything, including the a and b, are in terms of u. And then everything works out. Now, it should be noted that you could, down at this step, put in an x and use the 0 and 1/2, but it's not very efficient. And I would recommend doing it this way. So here are some common mistakes people make. The first common mistake is they forget to change their variables. So they'll put the 1/2 and the 0, and then they'll just treat it like this, and that's incorrect. The second thing people do is they'll change the variables, and then they'll put the u in terms of x back in, and then use these numbers, which is also incorrect. So whatever numbers you're using here for a and b, just make sure that you're subbing them in for the right variable. But what I would recommend doing is just getting everything in terms of u. Generally, it's a lot easier to do. And so let's do one more example. All right, so the next example is kind of similar to ones we did before, but we're going to make a definite integral. So, for example, I've got the integral from 0 to 2, of x over the square root of x squared plus 4 dx. Okay, so I recognize that I have to make a u substitution. So this is going to be equal to, I'm going to rewrite it so it's a little more u sub friendly. So 0 to 2 of x squared plus 4 to the minus 1/2 times x dx. Okay, so the first thing I need to concern myself with is what form of u substitution am I looking for. So the form is going to be power rule form, so that's u to the n du, where n is going to be negative 1/2. The other thing I need to concern myself with is that this 0 and this 2 are in terms of x. And after I make my u substitution, I'm going to have to get them in terms of u by changing the variables. So the first thing, let's just do the u substitution part. So u is equal to x squared plus 4. So this term is going to be u to the negative 1/2. And that leaves me with subbing the second part, which is x dx. So differentiating u, du is equal to 2x dx. And I'm going to lock up my x dx because that's what I need to still sub from the equation. And so x dx is equal to 1/2 du. So this box is 1/2 du. All right, so now what I'm going to do is kind of do this like a regular u substitution problem. So this is equal to 1/2 the integral of u to the negative 1/2 du. But now I need to change my variables. Okay, so if I look above, u is equal to x squared plus 4. When I look at my original value for x equals a, so when x equals a, which is equal to 0, then to find my u of my lower bound, I'm going to put 0 into, so I've got 0 squared plus 4, which is equal to 4. So over here, I'm going to put my lower bound, which is u is equal to 4. And then I'm going to find my upper bound. So when x is equal to 2 from the original equation, then my u value is going to be 2 squared plus 4, which is equal to 8. So I'm going to put that back over on my u subbed integral over here, so u is equal to 8. So now I just perform the antiderivative and then evaluate from 4 to 8. So I've got 1/2, and then the antiderivative of u to the minus 1/2 is going to be u to the 1/2 over 1/2. And I'm going to evaluate that from u is equal to 4 to u is equal to 8. So I've changed my variables, so there's no need to put the x back in. Let's see what happens here. This 1/2 cancels with this 1/2. So basically what I have here is I've got the square root of u evaluated from 4 to 8, which is going to be equal to the square root of 8 minus the square root of 4. So that's going to be equal to 2 square root of 2, which is what square root of 8 is, minus the square root of 4, which is 2, which I could also write as 2 times the square root of 2 minus 1, whichever you prefer. And that's the value of this definite integral. So again, whenever you're dealing with u substitution and definite integrals, your a's and b's are going to be in terms of x's. Make sure you get them in terms of u's, and then you can just throw the number right in. It is worth mentioning that you don't have to do this, but if you don't do this, you put u in terms of x down here, and you can try it and it works out just the same, but just be really careful that you are using the correct a and b for the correct variable. For efficiency, and it's really a matter of efficiency, I would strongly recommend using change of variables and just getting your x's in terms of u's, because there's generally less math involved and it's a little bit neater solution in the end. Okay, so that's it for 4.5. We are done, and that's cool. I got Friday's 55-minute lesson done in looks like 42 minutes total. All right, so remember that this section 4.5 homework is due on Wednesday. All right, have a great rest of the 3-day weekend, and I shall see you on Tuesday.